Alrighty, here we go. 1 minute early, starting some crazy stuff. So, I've been doing this for way too long, but I'm going to be attempting to, doing another iteration of the system, which is highly patternistic, which can store any and all data. It really takes the fun out of modeling because, you don't need to sit there and think about what goes where anymore. But you do have to think about how things are classified, so that's where this thing comes into play, this whole structure. Um, I have this seed set up, so basically I have um, the system database and interface database. Because the last couple times I've documented this process, it took a long time just to get to this point. So I'm going to start from this point and try to create objects and edit data on, as we go along. But I have this handy dandy thing that I can draw on. So I can give a visualization, which is different than my previous iterations. So what we're looking at right now, what this system is that we have this thing, this data management system, not database management system, but we manage data. That is the core of what we do. And we need to design things for the system itself, the system as a whole. So we're going to normalize every little piece of this system. We're going to normalize the system itself, the databases that go into the system, how the tables are created, and how those relationships of the tables are created and what shapes they are, because we only have so many things, so many shapes. We have a relationship shape, we have a shape for reference data, and a shape for domain data. So things that change very rapidly versus reference data is something that's common knowledge that doesn't really change. Uh, Easy example would be, all of these things have very specific attributes and things attached to them versus people. People have names and numerics and identifiers and addresses or contact. So people would be a domain versus reference data. If you're not worried about language, the etymology of language, then language would be a reference data for your company. However, if you're interested in when things died, when languages died, how long were they spelled, like all the attributes that come with language, because that's what your company does, then we would focus more on the domain. So we should be able to go from reference to domain pretty easily. And that kind of brings us to this model of this is how we're going to make SQL create everything for us. So we have the database, we will normalize these shapes, we will normalize access through views and through procedures, triggers to record history, archive, and snapshot data. Databases will come in patterns of 4, so we can separate data and optimize the physical layer. So we will have main, which is the 2 databases that you see, snapshot, history, and archive. And we will be making this system create all of this for us, including the functions, the views, everything. Everything. So if I go back here, you'll see we have tons of different views, and each of these views will have triggers on them to prevent doing something. So we can control the flow of data too. So very complex system, but it's very simple once you start seeing the patterns involved. So my first task today is going to be to get my database units set up, because I'm starting with main for interface and main for system, but I need that unit created. That's part of the definition. So I'm going to look at what's going on in this create script. And I'm going to say all these options we don't really care about at this moment. So we will do something later. So my create database statement is pretty simple. All I have to know is the name. So I need something to generate a name, something to generate a path, and a file, and the rest of this stuff can be static. Come on. So I will have to have my file path and I have to generate this name. So looking at this system, since I do have some data in place, tree for data set, and I want a tree for the definitions. This is kind of some of the data that I already have in this system. My data sets, whether they're tables or files. So I have log file types and my definitions on how we're going to name something. So I have definitions for naming. So let's see if the definition tables definition type ID equals the definition type ID in the actual definition table. Oh. So with these definitions that I have in the system, in this tiny kit subject or shape, I have naming for what I need. So I have the database file name and basically naming an object what a file should look like given oh, what it belongs to. So naming of object, the primary name for a database file that is the default. So if I look back at my create script, I have my default. And I'll have my log, so I will have a log. So dissecting this, since we have to, let's see. What would I need? So declare, actually file names. And I use user-defined types for everything I do. That's the level of normalization that we're taking in the system. So these user-defined types actually define what kind of data we're storing. So whether we are storing names or descriptions, we are normalizing every aspect of the system. And doing this kind of prevents, I have a name. This wouldn't happen in the system, but I have a name in one table. It is var 100, and I have a name in another table. It is var 75 or var 99. So we create this gap between, or we lose the consistency on this is what this is supposed to be because a new developer came into the system. And that is why I'm using user-defined types, because now we get to define, hey, this is a generic text value, which is 100 characters, or this is an abbreviation value. So I need the file name for default, file name for log, and I will need the file path. So that should give me file name default, file name log. Let's see, file path, file name log. I'm going to use tokenized scripts to create these things because I should just be able to call a procedure and send this information in, and it will be able to recognize the path I have defined or will have defined and pull that information. So it's data driven. So all I have to do is say, hey, I'm trying to create interface, and it will know what that's supposed to mean. So it's not just this one database, but it's my 3 other databases. So first is trying to figure out what this name should be. So I'm going to comment all of this stuff out and say, I need to generate this name. So the name is going to be in this format. So I will need to get the definition for the object prefix or object identifier, whatever's coming in. So input for database subject. The type of database, which would be main, snapshot, history, and archive. Because we want different states of data. So if I have all my main data in one database and all my history data in another database, I can store the history data on a crappy drive or another server. Because we can use synonyms and all that stuff to really isolate and improve performance on exactly what we're doing. And then finally, after I have my prefix, my subject, my type, I'll need to know basically the suffix. So with my definitions tree, I basically need to filter this down to get a very specific type. Naming object identifier for a database file. So part of this system is having it automatically create things for you. So I have brought these functions over because interface main is where all of our code's going to go. We're not going to store procedures or functions inside of system main. And we're not going to store tables inside of interface main. Interface will be the connection string for any outside application. So we don't have to worry about these 72 databases that we're going to have. We just have to worry about this one single thing. And even on top of that, interface main, because it will have a main snapshot history and archive, we're going to create database triggers. So every time one of these procedures changes, it will automatically store that version of what it was. So we can accurately track, revision control without an external application. So I need to find, back on topic, the name object identifier database file. And I have these, get type. Where is it? Oh, there it is. For the definition, where part of the system is a lot of people use where ID equals something. And we're not doing that because what if the ID changes? What if I want to give you my code to run on your system? And I have where ID equals 28. What if your 28 is different? So this concept of key name that's inside every single table is what we're going to use in code. Every single table has a key name. The rule is if the key name is null, we can go ahead and assign it to something. But if the key name is not null, then we should not change it because it will totally mess up our system. So this ID right here is for the operating tenant. We don't have that data yet. It would belong in the database. This is who owns the data, and the first record will always be the system. So I want to get the type ID for the naming object identifier database file definition. So I want the definition type for naming object identifier database file. And when I get that, from the select, where the definition type ID is in, what should I get? FS. So that is exactly what I want to create this first part of the system, or of the file. So my incoming parameter would be, let's just use interface for right now. Interface and system will be the first two database units that we create. So for interface, this will be my subject name. And we'll do interface. And actually, this iteration is going to be focused on overloads. So instead of altering functions to add more or remove parameters, we're going to try this iteration, first time I've done this, with a payload. So we want it to be JSON because it's just lightweight. So subject name will be interface. And because we want to be very specific, atomic, we will have a subject type name of main. So actually, let's use key names. Interface and main. All right. And then we have our operating parameters. So select subject name. Actually, I'll change that to key name. From OpenJSON, so SQL, I think 2016 and plus, OpenJSON root with the subject key name will be at, or will be a generic text, and it will be located at subject key name. Subject type key name will be generic text and located at subject type key name. Boom. So I should of course. There we go. So I can pull from this JSON. So in my store procedure, I'll basically have an operating tenant, a payload, and a response with a flag that says it was successful or not. So my response could be actual data returned in the JSON format, or it could be an error message. And having this type of overload allows us to make the system generate the data for us, or generate the code for us. So now that I have these specific data pieces, I'm still going to need this, but I have the definition name. So if I look at, let's see, primary name for a database file, say regex replace, let's replace tab with quote, comma, quote. And get the definition type ID again for something else. So we're looking for the primary name, and it's a template. And I want to store this because I'm just going to use it twice. So definition type ID. Oh, for the definition type ID. So I got 3 of them back, my default log and my primary subject area. So I want a very specific one. Default and log. So I'm going to move. So I'm almost ready to generate my definition. So let's do definition and type, or no, definition key name will be default. because I don't like typing, so I'm going to make this do as much as possible. Oh, I said type key name. It's not what I meant. I meant regular old key name. Boom. Lies. Oh, not lies. So I got my default, and if I say I'm looking for the log file, I will get my log. Awesome. So because I need to generate these names very often, I'm going to create a function that will do that for me. So with my standard, I go look this up. In that same table that I pulled fs or fg from, it will say fnc is my function. So I want to transform. I'm going to give it a payload and then transform it into a name. And for this one, it will be for a database file. So, like I was saying, this particular item, I want an operating tenant. So group ID tenant operating. And the JSON payload. Because in the event that I need more parameters, I don't have to alter this function, go everywhere, or figure out where this thing is called, and then update it for the new parameters. I just want this very consistent thing. It's going to return generic text, which is 100 characters. Here's a little trick. If you are wondering what 100 characters looks like, then think of this sentence to help you. Let's see if I actually was able to do it. Man. Yep, there we go. If you're ever wondering what 100 characters looks like, then think of this sentence. So this is a pretty long name that we have. So generic text should be fine for everything that we do. So it's going to return my name. And what we've done was basically set this up. So my payloads, the incoming items, I will need the subject and all of these key names to pull from the JSON. I will need to get the definition type for what the tokenized name will be. So just so we can see that again, I will need this item. Nope. Copied too much there. We'll just need the definition name. And then I will copy this so we know how to format our replacement. And I will need the prefix, the FS. What is the identifier that we are using? So yes, I could have removed this and just put FS, looking for the database name and the database type name, but then that is hard-coded in here. Thank you very much for following. So we just want to be more data driven. We want to be able to change our code by altering data in a table. This allows us to avoid, moving. Well, we can split it up. When you think of DevOps, we can move code, we can move data, we can move services. Like everything is atomized. ACID. This is what we're supposed to be doing. This holistic normalization. So, database file. This will get me my FS. This will get me my tokenized name. And then we will replace everything and return our file name. So looking at this tokenized name, I'm going to actually change this up. Instead of subject, I am going to use database because that makes more sense. So database key name, we will eventually line up with this. So do I have any databases in here? I do not. Bah. Okay then. Database key name. Is what it is. All right, so definition type ID for the template. The definition name for the template. Yep. The definition name for the identifier. And the file name to return. Generic integer. So what is this one for? The template. So I should be able to create, I'll just do a series. Set file path, or set file name equals our template. Set file name equals replace our file name with something, and we're going to do this 3 times. We're going to do this 3 times because of this. So replace tokens with values. We're going to replace our identifier token our database name token, and our database type name token with our definition for identifier, our database name, and our database type. So that should give us what we need. However, this is only for, actually, I'll wait and I will do that when we get our subjects, because when I look at, let's just do this. When I look at my many files, I actually have one for subjects. And the thing is with subjects, there are more parameters to determine what type of file we are creating. And that is because to optimize the physical layer, we store our cluster data, the actual table data, on different files from our indexes and our large binaries and our columnar indexes. This will allow us to move these to different drives, not just the history database to a different high-powered, low-powered server, but also to put, our different things somewhere, our different types of data. Index data is usually meant for rapid access of that record or records, so we might want this on a very high or fast drive versus our large storage. It's just large storage, so maybe we don't care. But this allows us to make that decision where we wouldn't otherwise have it with just a primary file group. So on top of that, so I have reference data for all of our reference data, but I also have relationship data. And you can't see it that well, but this is REL. And how this relationship table is set up is we will be able to relate any table to any, or any table's record to any table's record. We don't need a junction or relationship table for every relationship. We don't need one for, I want to link a parameter family to a data set. We don't need a table for that. We're just going to use one. That's the power of this system. Anyways, I digress. We're going to eventually need to create these types of files. So we will want to come back to this function to make other adjustments, like saying, hey, can we get the subject information? And then say, if the subject information is null, then don't try to replace it. But technically, we can just blindly replace things because that's how, that's what SQL allows us to do. If it doesn't find the token, it won't replace it. Ugh. So this should be good enough for our initial file. So I can take all of this code and get rid of it. Come on. I'm going to keep the payload. I'm going to keep my file name templates and all that stuff. Right? Yep. Definition type ID. I'll need the file path, and I'll need these two file names. So I can get rid of this crap. Boom. And replace it with a function. Select, transform, database file, who's my operating tenant, and what is my payload. So I will replace subject with database. Actually, it's subject key, database, and subject type key, database type. So this should give me close enough to what I need. Just to verify. Yep. So I need the name separated from the default. Okay. So that is my issue, this is what I'm talking about, data-driven code, is I can say, you know what, if I'm trying to generate names, I actually don't need the extensions. So let's go ahead and get rid of the extensions. And then it looks like, our file group. So I'm just get rid of the extensions. Since I'm sending names and not key names, I can actually say interface main. This is a key name, so I want all my key names caps so they stand out and you can read them. FS interface main log. That's system. FS interface main log. Yep. And what if we say we want default? We get default back. So pretty simple. I can actually say, if I'm coming in here, I want this payload. Let's see. Let's say payload for the log file. And the payload for the default file. So boom. So now I have basically my file names for default and for the file path. But I do not have one for what database am I creating? Well then, how about I just say create a function for transforming the name of a database. Well, I need the database name, I need the database type name, I need the definition key name. Well, let's say it's not a database file, it's just a database. We just want the database identifier. We're going to assume that we have the identifier, the name, and the database type name. So maybe we say, instead of returning the file name, we return the database name. Oh, that is right. That is right. So database name complete. Because, well, we're overloading. And I want this to look good because I'm OCD or something, I don't know. But let's say that's all we did was some copy, find, and replace type stuff, and we're going to send it a payload. Actually, I messed up on that because there are some things in here that we do not need. We do not need this, where is it? This key name is irrelevant because we only have one type of database. So I want to make sure that I remove that. So essentially it's going to pull out interface and it's going to pull out main. It's going to look at how, let's just kind of look at that. It's going to get the ID of 2 and then it's going to get the definition for the ID of 2. Identifier, database name, database type name, type name. So instead of just running it, just to get a little bit of information about what's happening here, all I had to do was find and replace um, my file naming type to get my database name. So I should be able to send it any sort of payload that contains that information and get the database name. So get my database name. Transform this to a not database file, but a database. Doesn't really matter what payload I sent it, but it should create this DB interface main. So actually, let's say we have a primary. Primary payload. It consists of all this information without the log. If I want to use the log, it's going to be my current payload. And then it's going to be we're going to modify what we're looking at, and we are going to append to the definition key name a value, which will be log. So I'm saying with this is going to inject our definition key name here. So I have this primary focus or context, and then in here I can say, you know what, this is a very unique case where I have to create two files for one object, so therefore I'm going to create two files, which means that I will do this for the default. But, oh, yeah, we want our key names to be that. So this should still work. I haven't used JSON in a while, but hey, it did not. Come on now. Oh. Nah. My bad. Pens for arrays. So, cleaner code, shorter path, not so much to work with. We have our interface and all that. So if I wanted to create the history database, it would do everything I need to do that. So we have, at this point, our database name, our file name for the default, a file name for the log, but we need the file path. So we should define this. And did I define this? I did not. We don't want hard-coded data. So let's say we give it a path. Because maybe right off the bat, you want to create a database on a different path. So let's do that. Actually, I'll just go steal the path from a create statement. So this is the path. And actually, this is a good idea. Oh, come on. Because what this should allow us to do is define what type of path should go where. Meaning, when we get this data in, before we get this data, we could say, hey, we want an external file path. So the drive letter would change, or we can create a data set or database. A folder is really a database. I know, weird. That has, this is our primary folder, this is our secondary folder or location or whatever. So we can overload when we're creating this database, it will know where it's going to store this data. So it's actually a good idea, and curious to see if I need to escape this. Yeah, I thought so. Unfortunately. What? Doing it wrong? Okay, there we go. I was doing it wrong. Whatever. Not perfect. Okay. So now we have our path. Does our path contain the slash? So yes. Slash. Then we have our names. So let's do operating parameters. File path. Awesome. So let's say we script this up and see what happens. Let's just see what it prints out as. So we have a SQL script. It is the base template. It is of the data type dynamic SQL. And then we have the script that we will want to execute. Keeping these separate really does help. We should also have parameters. In this case, we will not need them, but that is how we would format that. So here is our script base. So in initialize, we would have this. And I will replace the single quotes with double quotes because we are setting the base as this script. So that should create our database. Now we can say, select the execute version is the base version and repeat that pattern that we had just done. So I'm gonna delete all this crap. Boom. And go back here. These are just patterns that, this whole system, designed on patterns. So we have this token, this very dynamic piece of code, and then we are going to replace this data with other data. Yo dog, heard you like data. So we will have the database name, the file name default, the file log, and the file path. In our tokenized script, database name, file name. Whoa, glad I saw that. But I would have seen that anyways. Default, log, log. Okay. Database name, database file. No, file name. File name, log, and file path. Well, there we have it. Create database interface history. Looks like it's storing to the right locations. So let me take this and see if it has any issues. And it doesn't look like it's picking up any issues. So my select statements that I don't need anymore. Bam. So instead of printing it, execute sp execute SQL, and that will be it. So this is how we're going to create a database. Unfortunately, we need another piece to this puzzle. I just realized. No. There we go. We want to make sure this does not exist before we try and create it. So let's say we exit out before we do any work. So if not exists, actually, I will be right back. Sorry. So we want to make sure that we're not doing any work or as little work as possible. Before we attempt to run this. So I'm going to take my database name generator, or get me my database name. Actually, shouldn't be sending it default. Oh no. Yeah, I should just be sending it the payload. So I want to make sure that if it doesn't exist, we can do our things. That's it. But if we think of this from a procedure, we will want a response. If it doesn't exist, does that mean, or if it does exist, does that mean that this procedure is not going to be successful? But there are other things that we should be doing. Not only do we want to create our databases, we want to make sure that they're in our database table. So, well, if the database does not exist, let's go ahead and create it. However, or also, does the database exist? In our database table? And if it doesn't, we want to make sure that it does. So we have a tree for the database. I have some data already in here to determine what database we're doing, what we're looking at. So this is kind of what I was talking about. This iteration of the system is focused on overloading. If I were to have already created this procedure with database name and database type name and file path parameters, I would have to go modify this procedure and add another family, or actually a realm class family type. So, realm class family type. Realm key name, class key name, family key name, type key name. Realm. This is a relational database. It belongs to Microsoft SQL. It is a local database. It's not external to where we are running this stuff, and we are looking for the main version. So with this payload I'm going to send to this procedure to create a database, it's going to look up this information. The fortunate part is that now I really don't need this type name here, because I can get this information from my type table. So now I'm really working with these key names as they're supposed to, because I could say, oh, okay, I need the type name. So I will query my tree to look for this, get the type name, the actual name, and add it to the JSON payload. So there are different things that we can do to improve the system without having to change parameters and procedures. So now that I get my database name from this payload, I have to figure out if it does exist, and we want to insert it if it doesn't. So I will need the database type ID. All right. Database type ID. And that should be pretty easy to get. If it does not exist, please create it. So we will say, if database does not exist, create the database. Boom. If the database is not in our database table, insert the record. So I will want to get the realm class family type from here. Actually, I know I will need a key name, so I'll leave that there. Realm class family type. And if we, come on now, program correctly, we say select this data equals this data from open JSON. Oh, I see why. From our payload. And it's going to be from the root. What are we looking for? We're looking for this information at this location. I copied some white space. I should have removed that, but that's cool. Generic text at this location. Boom. Writing code with patterns. Easy peasy. So this should get our rem class family type key names. And then we should be able to select the database type ID from, I should have a function for this. Database type ID. Operating tenant, database, realm, key name, database, class, key name, database, type, key name. Oh, no. Family, then the database type key name. If the database type ID is null, we're going to want to, actually is not. Nah. We're gonna raise an error. And I forgot the format of this. I believe it's stat. There we go. Because, nope. So what is in here? Must have misspelled family. Nope, kind of. Yeah, so now I get my database ID. Where's this select coming from? I don't want that there. Oh, right there. Okay. Sweet, no raise error. That means I have my database type ID. Now, I need to know the system in which the database belongs to. As we move further into the craziness that is the system, what you should do is define what system that we are looking at. So if I went back here, I have my system. It is crazy. Function-based system with lots of pi. What if I wanted to Add the AdventureWorks system to my structure and the wide world importers. If, God, that's horrible handwriting. Here, I'll take my time. AdventureWorks and wide world. None of my patterns can be applied to these databases because they are crap databases. So by using the system, I could say, well, I have my own system and it's going to follow all of these things that we're building. However, I still would like to store these databases. So we're going to store them under a different system. And this will allow us to operate on different systems. So this data management system stores multiple systems. Real exhibit meme right here. So a database belongs to a particular system. And we need to know what system that is. So instead of writing this thing a million times, this is an application system. It's of the engine class. It's data and is the best. I'm going to create a function that will return this data. Regex replace. Operating tenant. Snippet. This will get my system ID. But what I really want is the system ID from the system select view, and all these views will make more sense later, where the system type ID is part of a type that will only contain my data. Should return a 1. Excellent. So again, instead of hard coding, we could easily say 1. Insert into database, system ID is 1. But what if we apply different rules and we can still automate the creation of other databases? Well, we don't really want to do that. We don't want hard-coded values. We want a more dynamic, a more fluid system. So I'm going to create another function. And I'm going to say this is a get function, and this is static. This will only return the same thing. So system ID for abstract SQL. It's not going to system. Oh, it's not going to take any parameters. Actually, I take that back. This is my iteration where just in case we do need them, we have them. There we go. It's going to take a payload, but it's just not going to use it. Maybe later if we need to add some sort of, what am I thinking of? Security checking, or hey, you can't really do this, or some sort of tenant specific functions, we can add it here. But we want the system ID from something that's just not going to change. And return it. So now when I do this for multiple things, because there are several things that require, well, there are 3 things that require a system. The database must belong to a system. The process must belong to a system. A process is a function, a job, a web service, like whatever you need. It has to belong to a system. And finally, a subject has to belong to a system. What is a subject? Everything. This is an interface subject. It contains 4 databases. We only have one right now. This is a data point subject. It contains 5 tables, 25 views, a couple functions, some defaults, some indexes, or defaults, indexes. So this is how the subject concept is going to allow us to, get an assignment. Someone says, I want to create this food application. I need to model food. And we're going to go into the subject table and we're going to say new record food. And it's going to create all of our objects for us because we can do that. This system stores whatever data because no business really has unique data except for, Facebook and the big FANG guys. But other than that, you're the same as everyone else. There's no reason to have 1,000 different person tables, one for each company, and sometimes multiple in the same company. So get our static system ID. Okay, right here. All right. So we created our database. We're going to see if the database does not exist. We're going to insert that database. So insert into database, insert. And this will tell us what we need. What do I want to do? I want to replace commas with a new line and then a comma. Yeah, because that looks better in my opinion. Boom. So what are we going to insert? This is the operating tenant. So if I'm a different company creating different databases, I want to make sure that that's what I do. I will need the system ID, and we will get that from, did I delete it? Gosh darn it. Or is it at the bottom? Yeah, it was at the bottom. We'll get my system ID from there. We'll get my database type ID. The database name will come to us in that neat little package. The description. So this is very interesting. We should be describing everything that we do. This will allow us to create a self-documenting system. Later on in the series, I'm going to build a React app that's basically just going to iterate through tables in the system main database and allow us to basically have this documentation engine that's built based on the work we do rather than trying to, document it after the fact. Let's document it during the fact. Um, for if I don't do it now, then I'm not going to do it at all. It's like this database was created. No. Let me come back to this. Abbreviations, we don't have any abbreviations or need any abbreviations. Column header, not for this database. Abbreviation is maybe you call interface int or interface main intm. Abbreviation exists in every table, and it's meant to get rid of industry-specific acronyms that you use at your job. Maybe you say OEM at your job, but OEM might mean something other than original equipment manufacturer. So that's where the abbreviations come into play, is to allow us to continue to hold on to that tribal knowledge, but at the same time decode it into something else. The column header is meant for pivots or to display on, some sort of UI. Is maybe you have a very long name, but it's referred to something else. We can fill up the column header. The key name, however, we do want to use, and we want it to be, that's going to be complete. Because I need the actual name. Okay, of the key name. The key name will be a capsed version of database name. Sequence is irrelevant. Display order is relevant. Is this database alive, and do we trust it? So 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. All right. So not every time that we get, maybe we want to create an inactive database, or maybe it's from somewhere else, so we won't trust it. So the more I think about this procedure, the more I want to say this is going to be specifically for this system and not a general item. We can create a general item later. So I'm going to say, leave it up to the defaults of the system. So at any point in time, when we create the default creator, which is basically saying, hey, trusted active flags cannot be null, but I have defaults for them. And the default for active is going to be true. And the default for trusted is going to be true. So by default, we're going to trust these and they're going to be active. In the event that I say, hey, we're getting a lot of traffic, I don't want this to be active at this time, or I don't trust all these new things, we can change that. So here we go. This should be good enough. If it doesn't exist, select that. System ID. And we actually just take this code. Copy paste development. Boom. Want the database key name to be the database name that we get, but capitalized from our payload, because that's all we care about. Boom. And I want to say, hey, just because if the system ID is null, must have a system. Now, here's another thing about these raise errors is that we will be creating later on a message subject. So we won't have this. We are going to be saying, hey, for the message subject, give me, the business. Actually, this would be system. The system realms of messages that violate rules. This specific rule is regarding system IDs, and it is absent. So this will give me a message type ID, which will give me content to add to our response and record in our execution table before we raise an error to break the try block. So we're going to have custom messages in the system, but for right now, let's raise an error. God, my cat is sawing them off right now. Boom. So this should be the complete, requires an operating tenant and a payload. Refresh. Come on. There we go. All right. If it doesn't get a system ID, raise error, we're going to get the key name. Key name doesn't really matter, but the operating tenant does. So I think we have enough to create a database creator in the sense, let's see. Yeah. So I have a procedure. What does this represent? We're going to put this under the system realm. We're going to apply this realm class family type, and I'll talk about this for a little bit, just so it really makes sense. 99% of our objects are going to have a realm class family type. Some of them worked, some of them didn't. I'll get better at drawing. This is a brand new pen. There we go. So we have the realm class family type. This has a realm ID. This has a family ID. This has a damn it. This has a family ID. This has a class ID. So this is our relationship. These are very generic. These are very specific. Very common subject to talk about is language, how we communicate. So we can use a realm to call it a spoken language or a written one. We have a class that could mean, actually let's say the class is spoken. Because this is where all my work takes place now, is I'm just figuring out how to classify data. I no longer have to figure out what column goes in what, or how do I build this object, because they're all part of a pattern. We say this is active, or a dead language, or whatever. Is it spoken? Is it written? Is it manufactured? What family is it? Is it Germanic? The type is English. Type is German. So we have the structure of generic realms to specific types. And each of these structures have this additional table. This additional table being the base table, where the base table has a type ID, and it is the actual data that we're storing. So given this language structure, now we can store our codes. And in our application, we have these choices. We could say, well, does this person belong to English? Or is this person ENUS? Does this person speak Germanic languages, spoken or written? So we have this type of classification that allows us to expand however we need without modifying the table itself. It's just data. So really, it doesn't go against this normal form idea of redundant data. It's not redundant data. We're looking at the entire chain. This is a record, not this. And I think too many people focused on, you know, uh, yeah, too many people focused on this being what to normalize that it really, you know, it got us to where we are right now. We're in a position where in our industry, everything is different. If I go to a different location, different contract, they model the same data, yet they model it differently. So our industry's only been is a pretty new industry. It's been alive for like 50 years since the 70s, I believe. Maybe, we can talk about before then, but really it's COD, voice and COD that uh, got us really where we are today. But all the normalization focuses on that record. What are the transitive properties to the key? And that is not the case. It's this idea, this concept. And this is the concept, language. It's the subject. We are thinking about the subject. There are different slices. Think about food, where we have meat, maybe um, what animal it comes from. And I should not use that. What animal it comes from and what part of the animal does it come from. And then maybe skinless, boneless, skinless and boneless. So we really have to think of this entire chain as our unique item versus redundancy on a specific table, because this is irrelevant now. It is this huge chain. I want to be able to have Ian US in here 3 times for spoken, for written, for gesture, for sign language. So in order to support ENUS as sign language, all I had to do was add one record to the class, family, type, and base table. No modifying any objects, nothing. And that is the primary focus of the system, is the classification. So when we look at this classification system, we're going to apply this classification to our naming conventions too. So this procedure belongs in the system realm. What type of procedure or what class of procedure is it? It's really an object creation procedure. So what family is in the database, or yeah, database family, or is it an object class? This is a system procedure. It affects objects. What about it? The creation of what type databases. And then we look at that most minute level or atomic level of what does it do? Well, this creates a database. It doesn't create a unit, it creates a database. So let's say create single. So this creates a single database. What does it require? Well, we need our operating tenant. We need a payload and a response. Now let's actually avoid the flag, do we? This is why you got to join the live discussion, is you could have a huge impact on this system. Should we add a flag to tell us if the procedure is successful or not by our standards, not by an issue with the SQL Server, but by our standards? And I'm going to say I don't know yet, because we only have one procedure now and it won't be that hard to update in the future. So we're going to take this payload, we're going to have this response. This is all the stuff we need to do. We don't need, actually we need this as our operating parameters. We should be able to take all this code and actually we want to go all or nothing. I use a snippet manager. Oh, come on, what happened? Oh, okay. So where's my catch? Here's my end try, here's my code. Here are my variables. Here are my initializations. Actually, should have that right under there. There we go. There we go. Yes, I do. My YouTube channel is I believe it's in my bio. You can check it out. I got hundreds of hours on this this concept, some optimization, some how-tos, like beginning stuff, but I can't do, I've tried to do for beginners and it's really hard because I don't remember that anymore. And I'm teaching my wife SQL and I don't remember what it was like to not know because it's been over 10 years. So I don't think that I can do that appropriately. So I'm just in the mad hattery of data patterns for way beyond people that have been in this industry for decades. Just because I got to mentor with a PhD in this subject. So thank you for asking. If you have any questions, man or woman or whatever, let me know. But I just want to create databases. If not exists this database name, I'm not sure I understand the question. If you're talking about these are variables. If you are talking about the ats, these are variables. Like, how would I explain this? If you are a computer, computers are not smart. You have to tell the computer you need to hold something. Okay. And it's different because MySQL, for instance, you can get away with not using these, and it's very case sensitive. So just depending on what flavor you've started with. Yeah. So this should create. Let's wrap this in a whole thing. DB create. If I can do everything I'm supposed to do, commit this transaction, else it will fail, especially with my raise errors. I want to figure out what happened and then roll back my transaction. We'll get deeper into all of this stuff. Oh, yeah. Roll back the specific transaction. Okay. So this is supposed to create databases for me. Can I make it create databases? I don't need any of this stuff. I need my payload. So let's get rid of it. Here is my payload. We're going to call this thing. Actually, come on, DevArt. Do me a solid. Control Shift Fresh. There we go. There we go. Middle live. What am I setting up? Okay. What I am setting up is a system that builds itself. Have you done data architecture work? Luggy 007. Or have you done SQL work? Because what we are setting up is a system that builds itself. It can store anything and model anything without us having to interfere, without us needing to figure out what column goes in what table or anything like that. It doesn't matter. People think of data deeper than they need to, I guess. Oh, totally hit the wrong key combinations. There we go. Yeah. So what I'm trying to do right now is full stack. Okay. So this is something that you'll never see um, unless you're in a very select few Fortune 500 companies, some government agencies. This is a model, and I'll show you these tables. To give you an idea of something that differentiates this model from something you might have ran into, is that people think a first and last name belong in a person table. But if you think about it, that is a name, and people have nicknames. For instance, Luggio7 for Twitch. So what's your Reddit one? What's your Twitter handle? So we have all these names associated with a person, but they can have many names. What's your first name? What's your first name now? And et cetera, et cetera. So I've created a model based on patterns that I use currently um, in health data that I learned about 60% of this from a PhD in our industry, in the data industry. And he's installed it for the United States government, not only at state level, but at a higher level and in food processing plants, in electronic engineering firms. So everywhere. And the the end all is that we want to go into this table, this subject table, and I want to say this is an interface subject. It is a database subject. The purpose is to act as the only access point for you. So your only connection string will be interface database, and it will be able to talk to all 72 plus of our databases. You don't have to worry about anything. It's the only thing in the interface database will be stored procedures and synonyms, or stored procedures, functions, whatever, and synonyms. No tables, no data. So that is all you have to worry about. But we also have a subject called system database. This is going to be a unit of 4 databases, which is what we're working on right now. Um, that will act as information schema, so we have more control. Like how? Yes, yes. That is something All I'm going to say is that I have a decision structure ready for the data database when we get there. That creates forests, decision forests. So based on my available parameters in the context, and this is this iteration, this payload, based on the information I have in this payload, what can I do? So the decision subject will be able to say, hey, I have a language and I have a gender, so I can make decisions based on this. It can make a decision and choose an action. That action could be to reevaluate decisions. So now you have machine learning. But yes, the answer is yes. And I could talk about this crap for hours. And we will eventually get there, hopefully sooner rather than later. But I'm rebuilding the system. I have built this system before without using this payload concept, but I want to see what's going to happen with this payload concept. Um, and that's basically what I'm doing. If you haven't been here during the beginning, is instead of modifying procedures, since you're full stack, I'm just going to be using these three variables for every single procedure. It's a payload which contains data. There's an operating tenant because it's a multi-tenant system, and there's a response, which is output. So whether you're getting data back in JSON format from a table or from whatever, or it's an error code, it's a response. It's almost like that redux concept of you have a payload, here's the stuff I'm doing, just figure it out. So this is the approach that I'm taking here because I've already eliminated the need to alter tables. Um, so I'm going to try to eliminate the need to alter procedures. Yes. So moment of truth. Bah. Makes sense. I know what I did. Sometimes I just hate SQL, but that's okay. Bam, alter. Okay, create database has to be the only statement allowed. That's fair. Well, I forgot some of these. Interface main already existed. It should have not created that. However, it should have given me a database, and it did. So, history. Part of the unit. A unit of databases are states of data: the main state, the history state, the archived state or deleted, and the snapshot state. So if I say I want the history state, say why did it fail? Insert, doesn't matter if that exists or not. Okay, print. Tell us why. You should. Name, file name. Path. Oh, path. Oh, that shouldn't really matter. Are you serious? How insane is that? Forward with back. Replace forward slashes with backslashes. And I've been doing this for a very long time and still run into crazy stuff that you really wonder, why does SQL even do that? Boom. Okay. Back on topic. Interface, history, snapshot. Archive. All right. So I created one full unit. Interface main, archive, history, and snapshot. Let's close all but this. So I wonder, select, actually, I want my tree. My database tree. It's all pattern based. From database select, where the database type ID is equal to the database type ID. On database name. So I messed up. Sweet. I got my database's name right, but I did not change the type key names. All right. So let's do that. So that was operator error, because that's awesome. Where's history at? Okay. It's the archive 3. Oh, I think I messed up my IDs there. Snapshot, archive, database ID is 3. Type ID is 3. But it doesn't look like I got history in there. Let's run history again. The right way. Ah, there we go. So now it's starting to fill in. All right. So that's double. So I see a problem where human error is messing this up. So I have to update 2 areas. I don't want to. So as I'm getting this payload, I should get the type name from here. Yeah, screw it for right now. All right, so what else do we want? I want system history, system main, which already exists. That's why we didn't get the printout. System archive. And system snapshot. Nice. I'm starting to get my databases in. Oh, okay. So we kind of have a database creator for a single database. But as I was talking about with this thing, we create a unit. And when we think normally, use that term loosely, people design one database. They do whatever they want with it. In this system, our database is actually a container. Say this is a database, and it contains 4 states of data. The main state, the history state, the archive state, and the snapshot state. So when we want to create one new database, it should create the whole kit. So that means I should be able to take this code create a unit. I want my comments. And I want these. Using the same pattern, I'm going to get a payload. You know what? Here's where I can take these out. So this is what I expect to get from anything calling this procedure. I will get my name, what type of database it is, and the file path. So in this procedure, say I'm going to create a new context where let's say new context is the incoming. Oh, I see. It's the incoming payload. And then I want to spell everything correctly. That's what I want to do. But I want to modify this current context. I want to say the root database type name will equal, say, main. Modify this context again. say the type key name is main. And then using the incoming, I'm going to send it forward. So this is almost like a React pattern, I guess. Here's my state. I'm going to set my state and then modify my state and then send it forward. But I need to do that multiple times. And to be honest, say that's what I want to do. Say update to use relationship table and definition to database type relationship. So instead of having this hard-coded code, what we're going to want to do, or what I'm going to want to do, is actually link this up and start making this circle. I'm going to link this up to our definition table, which right now it just gives us names, but we're going to say if you're creating a subject for this data or a database unit, a database subject, it's going to look up an ID for the definition and figure out through the relationship table what types it's related to. So then I can just iterate through the types based on the context of local. So when I say, hey, create an external relational MS SQL database, it's going to iterate through those types and say, all right, I need a main history shouldn't type so fast. Archive and snapshot. Versions of this data. So we have main history archive and snapshot. Reason why not so interested in modifying it right now to iterate through that list is because, well, this is a unit. There is no other subject for a unit. There are different table subjects, so I definitely want to do that right off the bat. A relationship and a reference subject plus a shared attribute and or an attribute and a domain subject, two other ones that we haven't done yet. But that should be it. So if I say this is what I want my payload to be, this to be my payload, and I want to say I'm going to create a database. It should create all four of them for me. Does it? Excellent. main, history, drive snapshot. Excellent. Sweet. So I now have a database creator, which is good. So I can start actually modeling things. But the unfortunate part is I'm going to have to do this for files. So I guess files, file groups are pretty easy. What time is it? 2 hours. I still got, man, I could do this for a year if I wanted to. 24/7, all Saturday, we're doing this. So let's create files and file groups. Because, well, since, I guess I'll just do that. That's what I'll do. I'll keep explaining the same subject because since we're here. All right. So I have the database. And it has 2 files right now. The default and the log. But to optimize the physical layer, here's an example. We can store files on different drives, databases on different servers. So we, in this system database, have two domains of data that we are modeling: reference data and relationship data. In data main, we're going to need reference data, relationship data, but also we're going to need people and groups because those are their own domains. I'll talk more about that subject when we get to the dataset creation. However, that's what we need to do is before we actually have tables on our database or in our database, we need places to store them because we should be looking, and we'll create jobs to look at default and be like, hey, is anything assigned to this? Like, why is this growing? It shouldn't be. It should be isolated. It should be modeled. But this will allow us the ability to have like a catch-all, like F sharp, in case we can't find something. At least, don't fail. Just use default then. So, in order to create a file, same kind of location, but we create a file for file groups. So we're going to need to create file groups. So given a subject, and I believe I called it the family. Given a subject family, we need a file unit. And files need a file group. So there are 4 items again in a file group and file unit. File group and file unit. We have data for the clustered indexes, the actual table data. We're modeling data for indexes, non-clustered, columnar, and blob storage. So since we're normalizing the entire system, this is our file and file group pattern, 1 for 1. So this should be pretty easy. And most of our code should be done actually. God, that looks like crap. That looks a little better, I guess. So, all right, if we want to store data, this is what we need. So we should have a lot of code that we've already created to use. One of those pieces is the name transformers. Thank you, Luggy. So this took a payload in. We got our database name from it. So it gave us back DB interface main. So we're going to need this piece in creating our file. Actually, no, we don't, because we have a database file creator. So talking about patterns. Oh, by the way, you asked about YouTube. I will be downloading these live streams and putting them on YouTube just in case you ever miss one. They will always be there. So yeah, but speaking of patterns, we have a database file name creator. Let's create a database file group creator. It's going to look for the same information that it needed. Definition, types, all that stuff. Except instead of database file, it's going to be file group. So if we were consistent, like we should have been, simple changing of 2 words, yes, should create a brand new function for the system. Meaning, with this data, with this payload, Control Shift R, DBO function, transform, database, file, file group, operating tenant, and the payload. So it's looking for database type. This is main. What else is it looking for? Definition key name, which would be subject. Is it key name or name? Key name. Database type. Subject. So if I run this, I do get it. But we need to give it more information. The subject family name and the dataset type name. This iteration using JSON payload, why I want to use JSON payload is because I'm gonna have to make these changes to both areas. Instead of adding a new variable to support what I need, I can immediately, let's see, subject family and dataset type. Subject family name and dataset type. Oh. Copy, paste, copy, paste. Now, what I like about the replace statement is that if it doesn't find it, it doesn't do anything. So I get nothing because it did find it. Let's say I went back to log. Oh, what are we doing? Let's see. Oh, I guess it's not as awesome as I thought it was. Reference. Boom. So it took some modifying, but whatever. So that means we can take our database file group. Let's copy this stuff. Is this our database file? No, that's file group. Let's go to database file and fix that because it will be exactly the same. Which means technically we can filter this down even further because these are tokens. We can relate a function to a token procedure and kind of use that decision mentality where we can iterate through these tokens and just replace a blindly because that's what we kind of do. But should be able to fix my file and fix my subject. So let's just try to do both. Actually, I think it's clustered. No, cluster. So FG, FS. So now we got little name converters. 2.5 hours. I think this is pretty good. Thank you all who have caught me live. I highly recommend that you try and do that if you see this on YouTube because, get some interaction, ask questions, what's going on, what do you think of, how do you think, things like that. So that is what this is all about, is learning how to think versus well, I guess even learning how to think is pretty subjective. But yeah. So I'm gonna get off. 2.5 hours. We created a procedure that creates chunks of databases for us and single databases, a couple of functions that will translate our context into something meaningful. So a couple hours, pretty good. I could easily create all 72 plus databases that I needed right now. So I think that's a pretty good place to be. Looking at my board, this board is public. So yeah, you can see where we're at, what we're trying to do. I created the unit creator today, not the database trigger, but we could do that. Should we? I think we should do this next, actually. Database creator, but not really these two either. So I think, actually, instead of going into trying to model to create more of our subject files, I'm going to jump into database triggers, like not a trigger on the database. So every time we update a procedure, it's going to start filling in our history. So after procedure alter, after function alter, we want to record what it is now. So that's what we should do next versus trying to model data because we want to keep track of our code changes. That's more important. first. So I think next Saturday, or maybe before then, depending on how I feel, we'll definitely next Saturday, maybe before then, we'll look at creating these database triggers to track changes in our processes and properly and automatically store those revisions. So thank you again for everyone who caught me live, and I will see you next time.